For a 1000 square foot home, a 100 amp service is likely needed. The wire size required for a 100 amp service is number 2 AWG copper wire. For a distance of 20 yards, a 1-inch Schedule 40 polyvinyl chloride conduit is necessary. The components of a 100 amp residential service include firstly, a weatherhead and drip loop, secondly, a disconnect switch which is the main breaker in the panel, and thirdly, conduit from the meter to the panel. For grounding, a 1/0 AWG bare copper ground wire connected to the ground rod and the panel should be used. The ground rod should be driven 8 feet into the ground. When selecting wire size for electrical services, it is important to consult the National Electrical Code, specifically Table 310.15. B16, which provides ampacity ratings for conductors based on insulation type and temperature rating. The table lists the allowable ampacities of insulated conductors rated up to and including 2000 volts 60 degrees Celsius through 90 degrees Celsius in free air, based on ambient air temperatures of 30 degrees Celsius. For a 100 amp service, using copper conductors with a temperature rating of 75 degrees Celsius, number 2 AWG copper wire is generally sufficient, as it has an ampacity of 95 amps, which meets the minimum requirement for a 100 amp service when applying the 83% rule for continuous loads. However, it is crucial to consider voltage drop, especially over longer distances. Voltage drop occurs when the voltage at the end of a circuit is less than the voltage at the source, which can cause appliances to malfunction or operate inefficiently. The National Electrical Code recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To calculate voltage drop, use the following formula: voltage drop equals 2 times the length of the conductor in feet times the current in amps times the resistance per foot of the conductor, divided by 1000. The resistance per foot of the conductor can be found in Chapter 9, Table 8 of the National Electrical Code. If the calculated voltage drop exceeds the recommended limits, a larger wire size may be required to reduce the resistance and minimize voltage drop. For example, if the distance between the meter and the panel is significant, say over 100 feet, it may be necessary to increase the wire size to number 1 AWG or even 1/0 AWG to maintain acceptable voltage drop levels. Conduit serves to protect the electrical conductors from physical damage, moisture, and corrosion. Several types of conduit are commonly used for underground service entrances, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and polyvinyl chloride conduit. Rigid metal conduit provides the highest level of protection, but is also the most expensive. Intermediate metal conduit is a lighter weight alternative to rigid metal conduit and offers good protection at a lower cost. Electrical metallic tubing is a thin-walled conduit that is suitable for use in dry locations but is not recommended for underground installations. Polyvinyl chloride conduit is a non-metallic conduit that is resistant to corrosion and is commonly used for underground service entrances. Schedule 40 polyvinyl chloride conduit is a type of polyvinyl chloride conduit that has a wall thickness that meets Schedule 40 standards. It is suitable for direct burial applications and provides good protection against physical damage and moisture. For a 20-yard distance, which is equivalent to 60 feet, a 1-inch Schedule 40 polyvinyl chloride conduit is typically sufficient for a 100 amp service using number 2 AWG copper wire. However, it is important to check the conduit fill requirements in the National Electrical Code to ensure that the conductors can be easily pulled through the conduit without damaging the insulation. The National Electrical Code specifies the maximum number of conductors allowed in a conduit based on the conduit size and the conductor size. The conduit fill requirements are found in Chapter 9, Table 1 and Annex C of the National Electrical Code. A 100 amp residential service typically includes a weatherhead, a drip loop, a disconnect switch or main breaker, and conduit from the meter to the panel. The weatherhead is a fitting that is installed at the top of the service entrance conduit to protect the conductors from the weather. It is designed to prevent rain, snow, and other debris from entering the conduit. The drip loop is a loop of wire that is installed below the weatherhead to allow water to drip off the conductors before entering the meter or panel. This helps to prevent corrosion and electrical faults. The disconnect switch or main breaker is a switch or circuit breaker that is used to disconnect the entire electrical service from the utility power supply. It is typically located in the main panel and is used to shut off power to the entire house in case of an emergency or for maintenance purposes. The conduit from the meter to the panel provides a protected pathway for the conductors to run from the meter to the main panel. It is important to ensure that the conduit is properly sized and installed according to the National Electrical Code requirements. Grounding is an essential safety measure that helps to protect against electrical shock and fire hazards. The grounding system provides a low impedance path for fault current to flow back to the source, which causes the overcurrent protection device such as the circuit breaker or fuse to trip and to energize the circuit. The grounding system consists of a grounding electrode, a grounding electrode conductor, and equipment grounding conductors. The grounding electrode is typically a ground rod, a ground plate, or a metal underground water pipe that is buried in the earth. The grounding electrode conductor is a wire that connects the grounding electrode to the neutral bus in the main panel. The equipment grounding conductors are wires that connect the metal enclosures of electrical equipment such as appliances, lighting fixtures, and receptacles to the grounding bus in the main panel. For a 100 amp service, a 1/0 AWG bare copper ground wire is typically required as the grounding electrode conductor. This wire should be connected to a ground rod that is driven 8 feet into the ground. The ground rod should be made of copper or copper-clad steel and should be at least 8 feet long and 1/2 inch in diameter. The National Electrical Code specifies the requirements for grounding and bonding in Article 250. It is important to follow these requirements carefully to ensure a safe and effective grounding system. In addition to the grounding electrode conductor, equipment grounding conductors are also required to be installed in all circuits. These conductors provide a path for fault current to flow back to the source in the event of a ground fault. Equipment grounding conductors can be either wires or metal conduits. If metal conduit is used as the equipment grounding conductor, it must be properly bonded to the metal enclosures of electrical equipment. Bonding is the process of connecting metal parts together to create a continuous electrical path. Bonding is important to ensure that all metal parts are at the same electrical potential, which reduces the risk of electrical shock. The National Electrical Code specifies the requirements for bonding in Article 250. It is important to follow these requirements carefully to ensure a safe and effective bonding system. When working with electrical systems, it is important to always take safety precautions to protect against electrical shock and fire hazards. Always turn off the power to the circuit before working on it. Use insulated tools and wear rubber gloves and safety glasses. Never work on electrical systems when you are wet or standing in water. If you are not comfortable working with electrical systems, hire a qualified electrician to do the work. The National Electrical Code is a comprehensive set of standards that provides guidelines for the safe installation of electrical systems. It is important to be familiar with the National Electrical Code requirements before working on electrical systems. The National Electrical Code is updated every 3 years, so it is important to use the latest edition. The National Electrical Code can be purchased from the National Fire Protection Association or from other sources. In summary, upgrading an electrical service requires careful consideration of wire size, conduit type, service components, and grounding requirements. Consulting the National Electrical Code and following all safety precautions are essential to ensure a safe and compliant electrical installation. Remember to properly size the wire based on the load and voltage drop calculations, select the appropriate conduit for protection, ensure all service components are properly installed and grounded, and always prioritize safety when working with electricity. The correct wire size, conduit type, and grounding are crucial for a safe and effective electrical service upgrade. Always consult the National Electrical Code and a qualified electrician for specific requirements and guidance. Always remember to disconnect the power before working on any electrical components, and use appropriate safety gear. Understanding these electrical concepts helps ensure a safe and reliable power supply for your home.